This first question, being a word problem, we need to make sure we read it carefully and know exactly what we're solving for. So it says here, all students in Mr. Green's class are either 17 years old or 18 years old. There's a total of 20 students in Mr. Green's class, and the sum of the ages of the 20 students is 345 years. What is the total number of 17-year-old students in Mr. Green's class? Okay, so the first thing I notice here is the fact that I have both 17-year-olds and 18-year-olds, okay, and a total of 20 students. So the fact that we don't know, we're not told how many 17-year-olds there are or how many 18-year-olds there are. I actually have two unknown items, okay? So in that case, that lets me know that I actually need both X and Y, okay? Because we don't know how many we have of either student. Okay, we are just told that the total number of students is 20 and that the sum of the ages of those 20 students is 345. Okay, so this is when we have two unknowns like this, we're going to create a system of equations where we have two equations, and based on our two bullet points, those are the two equations we're going to create. Okay, so a total of 20 students. Okay, well, what makes up those 20 students? It is the 17-year-olds and the 18-year-olds. So if I do X plus Y, the 17-year-olds plus the 18-year-olds will give me those 20 students. So that's going to be my first equation. The second equation is the sum of the ages of the 20 students is 345. Okay, so 345 is the total, and the sum indicates that we're going to add. But how will we find that total? Well, normally, anytime you have a problem and you're unsure how to solve it, solve a simpler problem. Okay, so let's say hypothetically, because we have 30 students in our class. Some of them would be 15 years old, some of them might be 16 years old. Now, to get that total sum of the ages, I would need to know how many 15-year-olds there were and how many 16-year-olds there were. Okay, again, this is just an example that I'm totally making up to explain my point. Okay, so if I had 15 students, the total sum of those 15, we have 10, if we have 10 students who are 15 years old, okay, that would mean that their age, the number of years between those 10 students, if they all have 15 years, would be 150 years total. And if I had 20 students that were 16 years old, if I do 16 times 20, I get 320 years between. So the number of years between 20 students who are all the age of 16 would be 320. And then I could add the total years together to find the 2 years to find, I could add the two totals together to get the total sum of the years that each person is, okay? So if that makes sense, then what we're going to do here is we need to know how many. We would multiply 17 by the number of 17-year-olds there are in the class. And we would also multiply the number of 18-year-olds that are in the class by 18 to get that total sum of years. Okay, and I apologize if me screwing up here misled you in any way. I hope the example helped. So now, that's the toughest part of our solving this problem. It is creating the equations. From here, my recommendation from here is you can solve it any way you'd like, but I find that solving by elimination is the easiest because it's the less number of steps. Okay, so elimination means my coefficients, when I add the two equations together, add to 0, hence eliminating one of the variables so I could solve for the other one. So because I'm looking for the total number of 17-year-old students, that's the variable I want to solve for. So let's eliminate y. Okay, and to do that, I can multiply this whole equation by negative 18. So because when I do that, I'll get negative 18x, but then I will get negative 18y, and then I need to multiply 20 times 18, and that will give me a negative 360. Okay, now if you notice, since I multiplied it's these two equations I'm going to add, you'll notice that now I have positive 18, I have negative 18. When I add, those will cancel. And I can do this as long as I multiplied everything, every term, the whole equation by negative 18. I haven't broken any mathematic rules. And so here, when I add 17 plus a negative 18, I get a negative x. And when I do 345 minus 360, I get negative 15. And obviously we can never have our leading variable negative, so if I divide both sides by negative 1, I get x equals 15, which is one of my answers. So that is how we would solve for that system of equations.